We have a cost function, and we want to find a minimum average cost on a closed interval. To find a max or a min on a closed interval, we find the critical points, and then we check the critical points and the endpoints to see which y value is the highest and the lowest. But first, if we're minimizing average cost, we're going to have to write an equation for average cost. That would be the total cost divided by the number of items. So C divided by X. In this case, we take the function given, and we're going to divide every single term by X. That gives me X squared plus 37 plus 250 divided by X, which we can write as 250 X to the negative 1. I'm using that bar over the C to stand for average cost. Now that we have our average cost function, we can find the critical numbers. To do that, we take the derivative, 2x minus 250x to the negative 2. I brought down the negative 1. Minus 1 gave me the negative 2. I'm going to bring the x to the negative 2 to the bottom. So my derivative is 2x minus 250 over x squared. I like getting a common denominator and writing this as a single fraction, so I multiplied the top and bottom by x squared, and now my derivative is 2x cubed minus 250 all over x squared. To find critical numbers, I have to figure out when does the derivative equal 0. That happens when the top is 0. And when does the derivative not exist? That happens when the bottom is 0. So add the 250, divide by 2, and then take the cube root, and the cube root of 125 is 5, and x squared equals 0 when x is 0. So on the first interval, from 1 to 10, I have to check my endpoints, 1 and 10, and then I have to check any critical numbers that lie between those endpoints. So I have to check my critical point of 5. And by check, I mean we take these numbers and we plug them into our original function, our average cost function, that is. So I'm plugging them into the x squared plus 37 plus 250x to the negative 1. When I plug in 1, I get 288. I plug in 5, I get 112. I plug in 10, I get 162. We're trying to find the minimum average cost, and the smallest y value there is the 112. So on the interval from 1 to 10, the minimum average cost would be $112 per item, and this happens when x is 5. If I want to find the minimum average cost on the interval from 10 to 20, most of the work doesn't change. I still find my critical points. I still have a critical point of x equal 5, but now since 5 is not between 10 and 20, I only check the endpoints. When x is 10, my average cost is 162. When x is 20, my average cost is 449.5. Again, I took those numbers, I plugged them into that average cost function. The smallest value is the 162. So that tells me on the interval from 10 to 20, the minimum average cost is 162. It occurs when x is 10. So again, to find a max or a min on a closed interval, always check the critical numbers and the endpoints. And you want to make sure that you're only checking critical numbers that lie between those endpoints.